So we just finished talking about vertical asymptotes, and now we're going to talk about horizontal asymptotes, which of course are the horizontal lines. Horizontal asymptotes are a little bit different than vertical asymptotes. In a vertical asymptote, there's no function that will ever cross a vertical asymptote. So nothing will ever touch it if it's vertical. If it's horizontal, it's possible that our function is actually going to cross it because a horizontal asymptote only tells us what happens as x approaches infinity or negative infinity. So there could be some stuff happening in the middle where our function actually crosses the asymptote. But as we approach infinity or negative infinity, that's what the horizontal asymptote tells us. So for instance, as x approaches infinity, we could have f of x approaching d either from above or from below. Either way, it's approaching that same horizontal asymptote. As you go towards negative infinity, again, it could approach d from above or from below. But that's as we're moving towards the negative x value. To locate the horizontal asymptotes, we just compare the degree, so that exponent, of the numerator and the denominator. So looking at these graphs, I'm looking at the degree of 1. So really, I like to sort of focus in on the two upper values. So this has a degree of 1 over a degree of 2. And when the degree on top is smaller, or when the degree on the bottom is larger, we will have a horizontal asymptote at y equals 0. So notice in this graph, this is approaching 0, this is approaching 0. So that's going to happen every time that the degree of the denominator is larger. Notice here, the degree of the numerator and denominator are the same. And when they are the same, we're going to have a horizontal asymptote at y equals, and then whatever those coefficients are. So 2x squared and 3x squared would reduce to just 2 over 3. So notice that's the point right here is y equals 2/3. So again, if I graphed this by hand, this would be a dotted line. If the degree on top is larger, as I have here in my last example, there's no horizontal asymptote. We're going to talk more about the slant asymptote, which is what this is, in our next section. So for now, if the degree on the bottom is larger, it's 0. If it's the same, it's the coefficients. So let's take a look. Here we have the degree on the bottom is larger. And if the degree on the bottom is larger, we know that the horizontal asymptote, would be the line y equals 0. Degree on the bottom is larger. Again, we said that was y equals 0, so notice where that dotted line would be on this graph. And again, notice, this is what I was talking about before. We've got this middle section here that actually does cross the asymptote, but it's not a problem because the asymptote tells us what's happening towards negative infinity and towards positive infinity. Here's another one for us to try. So looking at this one, you see that we have the same value on top and on bottom. And if I were to reduce the x squareds, that would just give me 3. So y equals 3 should be my asymptote, which would be right here. And notice what's happening. Negative infinity, it approaches 3. Towards positive infinity, it approaches 3. We don't care too much about this other little section of our graph right now. Let's try this one. We've got a horizontal asymptote using this. Notice the degree on top is larger, and when the degree on top is larger, we will have no horizontal asymptote. So that's what we're going to talk about next section when we talk about the slant asymptote. So this is no horizontal asymptote. It's actually going to have a slant asymptote, which we'll talk about later. So try this one and see what you come up with. For this question, again, I'm focused only on those highest degree terms. These have the same degree, and when they have the same degree, I'm looking at just reducing that to 7/4. So I should have y equals 7/4 as my horizontal asymptote. So again, that's that dotted line. I wouldn't worry about these, but that would be my horizontal asymptote.